The point now in these early days is to investigate physical systems of a sort that just haven't existed before. It's to make something that when you see or measure its properties, it's like, wow, atoms have never behaved that way before. Light has never behaved that way before. So the beginning of this is having few quantum things, whether they're electrons or photons or atoms, talking to each other in this quantum language, which if the system is open to the world, there's just too much noise coming in. Imagine you're walking along and trying to have a conversation, and so they start talking and boom, in comes a ping pong ball and hits them in the head. And so that constant bombardment disturbs any train of thought about having this conversation in a quantum language. A simple way to think about it is in the quantum world, everything, electrons are not little BBs, little tiny particles, little tiny bowling balls, but they're really waves. It actually goes up and down, just like a water wave. So if you have a nice, perfectly calm day and you're going to put your finger in and then have the waves spread out perfectly calmly, and that's like an electron moving through a solid. But if the wind's blowing, then you get all these other little wavelets that interfere with this beautiful single wave. Well, by the time you're through, you don't see the nice wave that doesn't have any coherence left. That's famously formulated by Einstein 100 years ago. It's called the fluctuation dissipation theorem. If these fluctuations of things coming in to mess up the quantum system, then the atom dissipates its beautiful quantum stuff into the environment. So all you have is just this envelope of energy without the actual waves. And the quantum physics is in the waves. So typically, to have really interesting quantum phenomena, you have to just get rid of all the interactions, all the people out there throwing ping pong balls. You gotta get rid of that. The point now in these early days is not let's make a quantum computer. It's to build quantum systems that are surprising with characteristics that just haven't existed. Now the boundary has pushed into very different parts of physics than I've ever been comfortable with or knew anything about. So that technology of how you do that, how you build those, my group knew nothing. But that's what you're supposed to be doing, you know? If you want to be at the cusp of the future, you have to be willing to fail. We've come up some climb and it didn't work. You better go down, try another way. You better believe it's scary. But it's an exhilarating intellectual adventure. In my position, wow, it's a privileged position to be able to explore. So if you know what you're doing, don't do it.